Today we are going to learn about energy, which is the ability to do work. Energy is transferred by a force moving an object through a distance. Remember, work has to have a force and the object has to move, otherwise no work is done. So energy is transferred by doing work. When work is done on an object, energy is transferred to that object, and work is a transfer of energy. So therefore, both work and energy are measured in joules. Joules has the abbreviation of capital J because it's named after Sir James Prescott Joule. When we look at energy, there are several different types. First, there's kinetic energy. Kinetic energy is the energy of motion. An object must have mass, it must weigh something, and it must be moving, so it must have a velocity in order to have kinetic energy. So light can't have kinetic energy because it doesn't weigh something, even though it does have a velocity. Potential energy is energy that is stored as a result of position or shape. For example, a ball can drop if it's sitting on a ledge. So this ball has potential energy. It could fall and have kinetic energy. A rubber band can have kinetic energy because when you stretch that rubber band, you are giving it energy because of its shape. So there are specifically two types of potential energy: gravitational potential energy and elastic potential energy. Gravitational potential energy depends on an object's height because that means it could fall. Elastic potential energy means an object is stretched like a rubber band, or it's compressed like, say, a spring. Or a ball that bounces is compressed and springs back, and that's why it has potential energy when it hits the ground. Mechanical energy is a combination of kinetic and potential energy. The reason they add those two together is because they are so easily transformed back and forth. For example, a ball that falls first has potential energy. Then it has, as it begins to move, it has some kinetic energy, but still has potential energy until it hits the ground. Then it gets more and more kinetic energy as it speeds up and less potential energy as it gets closer to the ground. When it hits the ground and compresses, it now has all potential energy. And when it springs back, once again it has kinetic energy. Then because of its height, it has potential energy. You get the idea. And so because kinetic and potential energy are so easy to transfer between them, they add those together and you have mechanical energy, which is the energy associated with the motion and position of everyday objects. Next is thermal energy, which is heat energy. Heat is the energy stored in an object because of the motion of its particles. Remember, a solid will shake in place, a liquid will flow and move, and a gas will bounce around the room. Chemical energy is another kind of potential energy that is stored in chemical bonds. For example, when you burn a log, the energy in the log is released as the burning occurs. A battery also stores potential energy in the form of a chemical reaction that is used to produce electrical energy. Electrical energy is also another type of energy that is associated with electric charges. Electromagnetic energy is another word for light. In case you have trouble remembering that term, look on the back page of your reference table. Here is the electromagnetic spectrum, the light spectrum. These are all types of light. You are used to dealing with visible light, but look, it's only a small portion of the entire spectrum of light. So radio waves are a type of light. Isn't that weird? Microwaves are a type of light. Infrared light, which is a form of heat. For example, when you stand in the sun and you feel the heat coming from the sun, that's the infrared light that you're feeling. Ultraviolet light is light. It's not visible, you can't see it with your eyes, but that's what gives you a tan. X-rays are a type of light. And gamma rays, which is a type of nuclear radiation, is also a form of light. These are all made of electromagnetic waves that can pass through space without having any sort of medium. It doesn't have to have a solid, liquid, or gas to travel through. It can travel through a vacuum with no no materials. Next, nuclear energy is also a form of energy. It's the energy stored in the nucleus of the atom, and that is released when the atom is broken apart into smaller atoms or when it's combined into a larger atom. There is a law of conservation of energy, and it says that energy can neither be created nor destroyed, but it can change forms. Therefore, when an object falls, gravitational potential energy is converted to kinetic energy. When it hits the ground, it converts to potential and then back to kinetic, but eventually the ball stops moving. So where does that energy go? It's actually turned into thermal energy. For example, if you sit here hitting your hand with a ball for long enough, you'll feel a little bit of heat and warmth because of the collision with your hands. Then it's also converted to sound energy. Hear the sound waves as it hits. And so the energy is converted to other types of energy. It's not lost, it changes forms. When you pick up an object, you do work on the object. I have just done work on this ball. My energy was transferred to this ball. Now, where did I get the energy from? Well, when I ate breakfast this morning, that was how I got the energy from the food. Well, where did the food get the energy from? Well, I had eggs, so that came from a chicken. The chicken got its energy because it ate corn, bugs, whatever, and the corn got its energy from the sun. The bugs ate something that also grew because of the sun. And so pretty much most forms of energy can be traced back to the sun. Not all. There's also chemical energy that comes from the bonds and compounds that are not related to living things and the sun. But most energy can actually be traced back to the sun. Another thing you need to know is that energy flows through systems. Just like we mentioned, the energy from the sun going into the corn's energy transferring to the chicken's energy in the egg, and the egg's energy into me. Here's another example of the conservation of energy. When you drive a car, the chemical energy in the gasoline is converted to heat energy when it burns the gasoline. The heat energy is then converted to mechanical energy by the engine. Remember, mechanical energy is a combination of potential and kinetic energy. But then lots of energy is lost. Well, remember, it's not truly lost, it's converted. This energy is used to overcome friction inside the motor, which actually produces a bunch of heat. And that's how the energy of your engine is lost. It's lost to friction by being converted to heat energy. But if you could add together all the bits of energy of any form, the total energy would be conserved. So if you added together the mechanical energy from the engine, the kinetic plus the potential, plus the heat energy converted by friction, then you would have the same chemical energy that you started with in the bonds of the gasoline. Another example of the conservation of energy is found in the motion of a pendulum. A pendulum is anything that swings on the end of a rope, string, chain, whatever. So you do work on the pendulum by applying a force through a distance. The pendulum now has potential energy. When you let it go, it converts to kinetic energy as it moves. The pendulum has all kinetic energy at the bottom of the swing. Then it's back to potential energy at the apex of the swing. Then back to part kinetic, part potential. All kinetic, it's in the fastest motion. Part kinetic, part potential, all potential. And so you see how quickly that converts back and forth. All that energy together is mechanical energy. So wait a minute. If energy is conserved, why does the pendulum come to a stop? Well, that's because of friction. There's friction here where the string rubs against my hand. There's also air resistance from the pendulum moving through the air. And between the two, there is enough friction to convert the energy of the pendulum to heat energy. And eventually the pendulum stops swinging. A roller coaster is another example of conversion of energy and conservation of energy. First, work is done as the roller coaster is pulled to the top of the first hill. Now it has potential energy. As the roller coaster goes down that first hill, it is converted to kinetic energy, the energy of motion. At the bottom of the hill, it's all kinetic energy. Then at the top of the next hill, it's all potential energy. Well, mostly potential energy. There is a little bit of motion there, so it does have still some kinetic energy. But it keeps going back and forth between kinetic and potential energy until finally the friction between the wheels and the rail converts enough of the energy into heat that the roller coaster finally comes to a stop. Remember, no machine or engine is 100% efficient because some of the energy is always converted to heat by friction. So if you have a ball on a ramp, what kind of energy does it have right now? What kind of energy now? What kind of energy does it have when it finally comes to a stop at the end? I have here a container with some sand in it. I'm taking the temperature of it, and it's 16 degrees Celsius. 20 to 25 Celsius is room temperature, so it's a little bit cold. I'm going to put the lid on, and then for 1 full minute, I'm going to shake this sand. What's going to happen is the mechanical energy, the potential plus kinetic energy of me shaking this sand, is going to convert the energy to heat by friction. The sand scraping against each other and scraping against the walls of the container is going to convert to heat energy, and the temperature of this sand is going to warm up. All right, it's been 1 minute. Wow, the temperature is up to 19 degrees Celsius. So it rose 3 degrees just from being shaken. In fact, that's a change of about 5 degrees Fahrenheit. So that's pretty cool. Finally, see if you can answer these questions at the bottom of your page.